We have our friend Hayden, who's a software engineer at Google's open source security team, Ghost. And he's focused on making open source software more secure, the maintainer of the Sigstore project, and prior to working in open source, Hayden worked at the Google Cloud Platform to provide cloud-based PKI. Take it away, sir.
Hello, everyone. My name is Hayden Blauzvern. I'm a tech lead and manager at Google on the open source security team, and a maintainer on the Sigstore project. Today, we'll be talking about some ways to get involved with Sigstore with some research projects. You've probably heard of Sigstore before, but as a really quick high-level summary, it's a set of services and tools to simplify code signing for artifacts. Code signing is not a new concept. It's been done for many, many years. But what Sigstore brings to the table is simplification, an easy way to bind identities that you probably already have to ephemeral signing keys. This makes it so you don't have to manage signing keys. It also adds a layer of auditability, where each signing event is written to a public ledger, a transparency log, so that identity owners can monitor those logs to see how their identities are being used to sign artifacts. There's a lot of reasons I enjoy working with the Sigstore community. I've listed a few up here, but what I want to call out is we aim to be agile. We aim to adopt research as it comes out and to be open to new ideas and figure out how we can evolve, whether it's improving security or privacy or a few other areas we'll talk about in a minute. As researchers, it's also really nice to be able to see real-world usage and get data on how your research is being applied. You also might find that there are scale challenges to some research, and this can come out by integrating with Sigstore, which has a good amount of usage and scale. So for the rest of this talk, I'm going to propose 5 areas of research to focus on. And some projects within each of them. Note that this list is in no way comprehensive, and if you have other ideas, let's talk more. We're active on Slack, and we'd love to chat more. Bring a design, and we can kind of go from there. So the first area to touch on is privacy-preserving protocols. As I mentioned, we use identities instead of signing keys, and those identities are written to a public ledger. This means that identities could include things like emails or machine identities, which could include information about private repositories or cloud projects. So some users may not want this information to be public and would instead want it to be redacted. There's a few areas to explore in this space. One would be the use of zero-knowledge proofs, which give us a way to redact information while still making signing events verifiable. And it also has the property of being able to let us see that the CA, Fulcio, actually verified a valid identity token. Another interesting construction to explore would be what's called a verifiable random function, or a VRF. This has actually been proposed for another transparency ecosystem, key transparency, which is being used for end-to-end encrypted messaging applications. They care a lot about privacy because they're working with sensitive data like phone numbers. I'm in no way an expert on this topic, but another area that would be interesting to explore is private information retrieval, or PIR. This would give us a way to query logs such that the log operator does not learn about what entries the user is interested in. This is particularly interesting for something like certificate transparency, where you're effectively revealing every certificate that you're verifying, and this reveals your browser history to a log operator. This is also important for binary transparency, or Sigstore, because you're revealing what you want to install, potentially, or revealing details about your development environment to the log operator when you have to query it. The next area of research is what's called witnessing. And this is a requirement for any transparency system to provide an append-only guarantee, meaning that entries in a log are not deleted or mutated. The role of a witness is critical. What they do is they query the log periodically and ask for what's called a checkpoint. Taking one step back, logs are represented by a data structure called a Merkle tree, which gives you 2 properties. One, an efficient way of computing what's called an inclusion proof, which is a cryptographic or set of cryptographic hashes that let you verify an entry is actually in a log, and a consistency proof, also a set of hashes that let you prove that between two log sizes, the log remains append-only. Witnesses will periodically request the current tree header, the checkpoint from the log, and verify a consistency proof between a checkpoint that they've saved and this new checkpoint, and then they'll update their current state if they've found that the log remains consistent. A large-scale deployment of a witness network is something that we've just started exploring, and this would definitely be an area that would be very interesting to research more. Related to this is what's called gossiping. Gossiping is where witnesses talk to one another to share their current state. And this mitigates an attack called split view attacks, where the log presents different views to different callers. Gossiping protocols are very much in their infancy, and there's a lot of opportunities to do research that would improve not just Sigstore, but the entire transparency ecosystem. The next area I'd like to touch on is verification or authorization. Sigstore does a really good job of simplifying signing, but we've kind of punted on the problem of verification and said this is a responsibility of the client. And I think we can do better and take a bit more of an opinionated stance on this. One area to explore would be leveraging policy languages like Rego or Q and integrating those into Sigstore clients to make it easier to specify how you want to verify an artifact. For example, what's the identity that should be associated with an artifact? Something else to explore is binary authorization. This is thinking more about the end-to-end pipeline of a package as it moves through a system and at what points should it be verified. Sigstore's done some work on this already. There's a repository policy controller. That's an admissions controller for containers in a Kubernetes cluster. But I think we can do even more and continue exploring this and coming up with some sort of binary authorization approach for open source. Another thing to look at would be the contrast between user identity and machine identity. We talk a lot about user identity in our examples, thinking about emails, but many builds are done on automation, on CI like GitHub Actions or GitLab or BuildKite. So it'd be interesting to explore different ways to represent machine identity, for example, thinking a bit more about how we can integrate more closely with something like Spiffy. The update framework, or TUF, is a framework for securing software updates. It mitigates a number of attacks that are common for software updates, for example, things like rollback attacks where software is rolled back to an insecure version, or freeze attacks where a client isn't able to get updates, new versions of software. TUF is very critical for Sigstore. It hosts our root of trust, which includes things like our CAs, root certificate, our transparency logs, public key. There's a couple improvements to TUF I want to call out of note. One is what's called identity verification using Fulcio. So the way that TUF metadata works is it's signed using keys. And one of the goals of Sigstore is to remove the need to self-manage keys. So we could instead leverage Fulcio and associate identities that developers already have with an ephemeral key and then use that in TUF metadata. Another improvement is on the client side, thinking about multi-repository search. And this is particularly useful for deployments where there's both a private deployment of Sigstore and a verifier needs to trust the public deployment of Sigstore. Right now, Sigstore clients have to be configured against only one environment, and it would be useful to be able to seamlessly search across multiple. There's also a lot of opportunities for improvements on the client side, thinking about implementing the TUF specification in other languages, or improving the existing APIs for TUF clients. The last area I want to touch on is verifiable time. Time is a critical component of Sigstore. We issue short-lived certificates, and so we have to rely on timestamps that are trusted to verify certificates once they expire. This is kind of a common pattern for code signing. Within Sigstore right now, we have two ways we get time. One is by leveraging the transparency log and using the entry upload time, and another is using signed timestamps that come from timestamp authorities. But in both of these cases, these are single points of failure, single points of trust. Roughtime is a protocol that distributes trust across a network of time providers and makes it possible to detect any time provider that has some sort of clock skew, whether that be intentional in a malicious way or accidental. There's a lot of opportunities here, whether you want to work on specifications, implementation of the client or server, or also thinking more long-term into the deployment of a network of roughtime time providers. So this was a really quick overview of some opportunities for Sigstore. Well, that's interesting. For anybody who cannot hear this, we had some emergency alerts go off on our phones. Anyways, so it probably does not include a link to our Slack channel. But if you're interested in getting involved in the research projects, come chat with us on Slack. We have a channel for research, or come ping me or any of the maintainers after, and we'd love to talk more. Thank you very much.